In this slide, we'll discuss the non-uniqueness of theta. What is theta? Well, we have seen in the last few slides that C can be represented in the rectangular form as well as the polar form, which is the magnitude and the angle theta. So we are talking about this theta here. Now, let's have this point, which is sitting at with magnitude Z and angle theta over here. Why is this not unique? Basically, is that if we add a 2 pi to theta, we are still back at the same angle. Or if we go theta minus 2 pi, because 2 pi is a complete circle, we are still back in the same angle theta. So in fact, Z equals to magnitude of Z, theta plus 2 pi is the same point as theta minus 2 pi, and it's the same point as theta plus 2 pi n, where n is any integer. So this shows that actually the complex number using polar notation can have many different forms, and when we use theta to be in the range of minus pi to pi, then basically we are expressing theta as the principal argument. Okay, and we use the capital A to denote that the theta is within minus pi to positive pi. This is as opposed to using the small a to denote that we can actually put theta in any of these theta plus 2n pi form, because theta plus 2n pi form lands exactly at the same angle with respect to the real axis anyway. So we now summarize the representation of complex numbers in the polar form. So we use this notation, Z equals to R angle theta, and we have this form is called the abbreviated polar form. We can also express this in a trigonometric polar form. What do we mean? Well, R is the magnitude, and what is this guy over here? Cosine theta plus j sine theta. Well, you'll realize that R cosine theta is equals to A plus R j sine theta is equals to plus JB. So Z is equals to A plus JB, and the real value A can be extracted from the trigonometric polar form by R cosine theta. Because look, if this is equals to R, which is the magnitude of this vector, R cosine theta is this point here, A, and R sine theta is B. So we call this form the trigonometric polar form, and R angle theta is the abbreviated polar form. Here R is absolute of Z, which is the modulus of Z, which is also the length of Z. We now show you some examples. So I'm going to put Z1, Z2, Z3, and Z4, four possible numbers in this 4 quadrant. Z1 is in the first quadrant because 2 plus 1j means moving along 2 and 1 along the imaginary axis. Z2 is on the second quadrant because it is minus 2 along the real axis plus 1j along the imaginary axis. Minus 2 minus 1 is minus 2 along the real axis minus 1 along the imaginary axis. And the last one, 2 minus 1j, is moving 2 along the positive real axis and minus 1 along the imaginary axis. So these are 4 numbers, and in fact the coefficients along the real and imaginary are the same, have the same magnitude, although different signs. So because they are 2 plus 1j, the magnitude is the same because it is 2 square plus 1 square square root. This is the magnitude, the modulus of the complex number. So it's all square root of 5. So notice that all the values of the modulus is the same. The difference, of course, is the angle. Now, angle, remember, should be from 0 to pi up to minus pi. Okay, so the angle can be from 0 to positive pi or 0 to negative pi. If it is towards the positive angles, then we are making anti-clockwise along the along the real axis. So 0.46 radian is here. About the second example, still we are making anti-clockwise, so this is still from 0 to pi radian. So this is 2.678 radian. And when we are at the third quadrant, we are doing this, so it is minus 2.678 radian. And on the fourth example, we are moving by a small angle, so it is minus 0.463 radian. So these four examples show you how to put these four numbers in rectangle form as well as in polar form. In the last slide, I will share with you what we mean by the unit circle. Basically, you have the real axis and the imaginary axis. You have the origin here, and you draw a circle of length 1. So this length is 1. So let's identify why this is a perfect circle. Well, if you move along the real axis, you stop at 1. So this point is 1 plus 0j. If you move up, it's 0 plus 1j. If you move left, it is minus 1 plus 0j. And if you move down, it's 0 minus j. And the radius along this circle is 1. So the word unit means the unit length. So the circle has a unit length of 1 centered at origin, and all the numbers along this pink dots, what do you call this? Circumference is the set of values on the unit circle. Okay, so the unit circle in pink is a circle of radius 1, and when we say the unit circle, the complex numbers on the unit circles, we're saying that all the complex numbers that have absolute value of 1 with angle theta from 0 to 2 pi.